Problem 5.4. Find the probability that a particle trapped in a box L wide can be found between 0.45 L and 0.55 L for the ground and first excited state. Here we have to find the probability of a particle that is trapped in between 0.45 L and 0.55 L in a box having wide L. This is a box having wide L, and the part of the box is 1/10 of the box width and is centered on the middle of the box. This will be the 1/10 of the box centered at the center of the box. Here x1 is 0.45 L and x2 is 0.55 L. Classically, we would expect the particle to be in this region 10% of the time. That is, this region will be 10% of the time. We know the equation to find the probability of a particle in between x1 and x2. P of x1 x2 equals to integral x1 to x2 modulus of psi n all square. Here psi n is the normalized wave function of a particle in a box. Psi n equal to root of 2 by L sin n pi x by L. Substituting this term in the place of psi n, we will get P of x1 x2 equal to 2 by L integral x1 to x2 sin square n pi x by L. Here x1 is 0.45 L and x2 is 0.55 L. Integrating this term, the final answer will be x by L minus 1 by 2nx sin 2n pi x by L from x1 to x2. Now we have to find out the probability of the particle in the first excited state, that is psi 1 modulus of psi 1 whole square. Here first excited state means n equal to 1. In n equal to 1, P of x1 x2 will be 19.8%. When we evaluate this equation, we will get 19.8%. This will be the probability of the particle in the first excited state. And we plot the graph. The graph will be like this, having peak value at the center of the center of the box, and this portion will be the 19.8%, that the probability of the particle in the first excited state. Next we have to find out the probability of the particle in the second excited state, that is n equal to 2. When we evaluate this equation in the term of n equal to 2, we will get P of x1 x2 equal to 0.65%. This is the probability of the particle in the second excited state, that is psi 2 modulus of psi 2 square. And the graph will be like this. This portion will be the probability of the particle in the second excited state in between 0.45 L and 0.55 L. So, our question is to find out the probability of the particle which is trapped in a box having wide L in between 0.45 L and 0.55 L. The part of the box is 1/10 of the box width and is centered at middle of the box. That is, this will be the region, and this region will be 10% of the time. The probability of the particle in the first excited state, that is n equal to 1, is 19.8%, and this will be the portion. And the probability of the particle in the second excited state, that is psi 2 modulus of psi 2 square, will be like this, and this will be the portion 0.65%.